Yeah, so this is the last segment of the day in the, let's say, more business track, more ecosystem track. And for this last segment, we are glad to have a speaker we love to receive at APIdays conferences. He has been at the first APIdays conferences 10 years ago. I don't know how many he missed, but it was too much, right? Or even if it was one, it was too much. Now, it's Mike Amundsen, and he will talk with us about programming the future of APIs with composable services. So let's have some cheers, some cheerings for Mike. Yeah, thank you. Woo, 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 woo. You can do that online too, right? Yeah.
Thank you,
Mike. Thank you.
Okay, thanks. All right, you're all here. Okay, so the topic is this idea of programming the future with composable services. I've been thinking a lot about this idea of composability, and I wanted to just share something I've actually been working on for quite a while, but I was always afraid to show people. So I'm kind of forcing myself a little bit to talk about it. By the way, this is me. This is how you find me on LinkedIn, and GitHub, and Twitter, and YouTube. I would love to connect with you, learn what you're working on, what's challenging. Most of the things I talk about are lessons I was taught by somebody else. I would love you to teach me more. What I'm going to talk about is actually going to show up in a book that's coming out this fall, which is a cookbook with O'Reilly, Patterns and Practices for RESTful Web APIs. This is a book I've actually been working on for quite a while, almost 2 years, which is really long for me. And I'm a little nervous, but it's coming anyway. So what do I mean when I say composable services? What does that actually look like? And then I want to talk a little bit about the difference between parallel and sequential tasks, which I think is the thing that we have to sort out if we're going to really do truly composable systems where I can just use your code when I want to and use your service when I want to and not have to ask any questions. Then I'm going to propose an example of what I think works. And this has happened, I've used this a handful of times. I'm going to try a little trick though. So I'm going to jump right ahead and I'm just going to tell you the end of the talk right now. That way if you really would like to see another talk, you can go and then you can get the slides later. Or you can maybe think about what I'm really saying. I'm actually going to talk about a job control language. This is what a job control document looks like. You can't really tell. I'm just telling you that it's here, believe me. Basically, it's a list of URLs, of endpoints. Endpoints to do a thing like execute a task, reverse a task, repeat a task, cancel the whole job, do the next task. It's literally a document of a bunch of URLs that actually depends on some other state information that describes the whole job. This is what composing is. I'm just going to list the URLs of all these services and all their endpoints for all the things they do, and then give it to anybody who wants it. And that's it. There's some security and other things around it. In code, this is what it looks like when I write a service that supports composability. I can actually read and write state. There's a shared state document. We're always freaky about state. State is here all the time. It's everywhere. And then you can start, cancel, restart, or revert a job. A task is actually one of the things you can do, such as execute or repeat or revert that task. This is all there is to it. It's not that tough. It's kind of like for those of us who write a lot of code, this is an abstract class. A composable service supports these things. This is what the actual network, what the diagram of composable services looks like. And this looks the same no matter what services you're composing, whether they're simple or complex, whether they're values, entities, aggregates, it doesn't matter. So what I'm really going to try to convince you to think about is that composable services is the future and that this particular approach can work for you. I'm not going to say it's the only way to do it. But I think it's one that has worked for me in the past in various ways, so I just wanted to kind of out it. Okay, let me back up a little bit. Why do I even want to talk about composable services? It's kind of been the holy grail for a lot of us. APIs, once you get APIs, you can just link them together. Most of us know the truth is I have to custom bespoke code every single API integration, and then if somebody changes it, I'm really in big trouble. I'm trying to avoid that. But here's why, another big reason why I'm talking about composable services, and this comes from Daryl Plummer at Gartner. He talks about composable business. Composable business is an organization made from interchangeable building blocks, and he doesn't mean just robots. He means the ability to apply creative people to the task in a short amount of time with a low latency and with a low complexity. And he talks about these 4 features: the ability to discover talent inside your organization, treating agility as modularity, the ability to move that talent to where it's needed, the ability to orchestrate that talent, build the right team in the right room at the right time, whether they're remote or local, and then give that team autonomy so that they can do the thing they need to do. They're the experts, not me, not leadership. Leadership knows what needs to be done. They don't know why or how. And that's where talent comes in. And this works great for composable services for us. Discovery, modularity, orchestration, autonomy, these are all nice buzzwords, right? These work. So if you want this composable business that Gartner and Plummer talk about, what you're going to need are composable services that animate that business, that make that business run, that make that work. So let's be honest. What does this really mean? What does composability really look like? Well, first of all, I'm going to have some canards here, some of the standard answers. It's not enough to be a service on the web. I'm on the web. I have a URL. That's not enough. You really need to be of the web, taking advantage of the web features, the ability to link from one place to another, the ability to use a form to ask for arguments, the ability to move that state from one place to another is really, really important. You're going to have to design in this composability. It's not for free. We know from working on all sorts of microservices and other things, you don't get services for free. You have to plan ahead of time, and you have to make them behave like other services. You have to, whether it's employing usability or security or observability, all these other the so-called non-functional elements, they're really part of the story as well. And composable services have to be fully described. Every detail of them, every argument they take, every method they use, every URL they use, and this description has to be available at runtime, not at design time. We're doing a pretty good job of describing things at design time, having things like open API documents or schema definition language files or protobuf. Those are pretty good detailed descriptors for design time or build time. But that's not enough. I need it at runtime. And at runtime, almost all of the things I mentioned can change over time. I'm going to change the URL. It's running on another server. We might someday change the number of arguments. We might even change the method, the HTTP method that's used. What if we're starting to use event services rather than RESTful services? Then I have a whole other set of challenges. So I have to be fully described all the time. So that's a hurdle. That's a pretty big challenge. And then there's this one that I mentioned earlier, a sharing state. We have this sort of aura around the idea of state and stateless. We use these terms like we think we know what they mean or something like that. And somewhere along the line, somebody got the idea that the only good service is a stateless service, which is nutty, because I can't hardly do anything with a stateless service except get an answer. What's the temperature? Can you compute the net present value? Those are stateless services. But if I want to actually read data from a data store, from a persistent place, if I want to do any computation and save it somewhere, if I want to share some information or approve a purchase order, that's stateful. So I have to share state. And especially when we start linking services together, sharing state's going to be really, really important. So I have to be fully described. I have to share the state. I have to design in this composability. And I have to take advantage of all the aspects of the web that we've had for the last 30 years. So having a public URL is not enough. I have to actually discover the URL. I have to look up somewhere, like a kind of a DNS. So what I use in my projects is a runtime service registry. It actually looks kind of like DNS. What I'm doing is I'm replacing a URL with a form. What I'm doing is replacing a fixed address with a variable. And that means that I can start to take advantage of things. I actually have a protocol service that I've been using internally called Disco, which not only reflects my agedness, but also reflects the idea of discoverability and interoperability. So I have to design in this idea of being able to compose. I need to be able to compose services that know nothing about each other. I need to be able to compose services without asking for permission from someone, without writing special code. Just like I use a link. I put a link in my document to your document, and then everybody can see your document. So I want to be able to compose services the same way. Basically, a function is not enough. I need a few basic elements. And what I'm going to say here is what I talked about earlier. I need to be able to execute the task. I need to be able to safely repeat it over and over again in case I don't get an answer, or I have to restart, or somebody else asks me. And I need to be able to revert it, to undo it. That's a minimum for a composable service. I have to execute, revert, and repeat. Now, I may also just need to cancel it outright. Maybe it times out or something like that. I should be able to cancel it as well. Cancel invites the notion that if anybody else is involved in my job, they have to be able to revert and cancel as well. So this is the minimum interface. Composability is available through a feature called idempotency. We have this thing in HTTP where there's safety and idempotent. Idempotent means you get the same answer every single time. You have the same strength. Put is idempotent, get is idempotent, delete is idempotent, post, oops, not. So it's a technical thing. Composable services are reversible. I have to have some rollback or undo feature. Now, if I'm just computing the net present value on a set of properties, then rollback is easy. I just say 200 OK, moving on. But if I'm writing data, I have to undo that data write. And of course, it's turtles all the way down. If that data write was handled by another job, then maybe other things have to be undone or rolled back as well. Maybe the data I wrote goes to 3 places. So fully described, what does fully described really mean at runtime? So we got a lot of this stuff from design time, like OpenAPI and WSDL and schema definition and protobuf and stuff like that, JSON schema. But I have to have a runtime description as well. The easiest way to do runtime descriptions for all the detail actions is a form, is an HTML form. Address, method, media type that I'm going to send in, media type I'm going to receive in, all the arguments I'm going to send. It's all right there. And we have enough experience with HTML to know that we can even indicate things like required arguments and optional arguments, and we can even do things like enumerated sets with select and so on and so forth. We have all of the technical details we need to fully describe every action. This idea of emitting and supporting forms is really sort of a key element in all this, and there's a language that I and some friends have used for the last several years called ALPS, which is Application Profile Semantics, which actually lets you describe these events as well. Now, the last one I wanted to talk about was state. State is really important. I need to be able to pass state from one service to another without knowing anything about that other service. Well, we've been passing state for 40 years through pipes in Linux and Unix and all these other things. Let's pay attention. Let's use the things that we have. Let's create the same kind of world on the web. So we can have a shared state resource. A resource out there that is just tied to our thread or our process or our instance. You can use any kind of security system you want. And that means that I can just write results into the shared resource, which may be needed to fill in forms for the next service in the list of services that I'm doing. Right? So I can always look at, somebody says they need a zip code. Let me look in shared state and see if there's a zip code. Right? Zip code, there you go, right in there. Right? So we can create these shared state documents. I need to be able to write to shared state as well. If I'm a service, I'm going to go ahead and write whatever the results are. These results might be the results of a computation. It might actually be the results of a data storage, a persistent storage write. That might come in handy if I need to reverse it, if I'm in charge of reversing it. So having a shared state resource is very, very important as well. So that's really going to be a separate URL, a separate resource that's owned just by the transaction. So the biggest thing that I think is a challenge is how self-describing this really has to be. We have to make up for a lot of description elements. But what we don't have to do is we don't have to describe the instance. We need to describe the abstract class. Right? There's going to be a URL here for revert. There's going to be a shared state value here. There's going to be these forms that you fill in. Then it's going to tell you the method to use at runtime. And that gets us a lot of the ways. Now I want to take a little side conversation here and talk about parallel and sequential jobs. We kind of skip over a lot of this, but the way I'm talking about this in the system that I use, the problem is the web is really a dangerous place. A task is one thing that you do really well, and that's where you execute, repeat, revert, or cancel. Tasks run in parallel. If I need to if I need to create a company record and contact record and a sales record, I should be able to create all of those at the same time. Not in sequence, but actually all at the same time. If one of them fails, I can back out the rest of them. It's no problem. So we need to kind of rethink how often we use parallelisms. Just as we have to learn to think a lot about async services and commands and how we write in systems like that, this is going to happen the same way. We're going to learn the same lessons we learned from EDA for the last 20 years. So a job is actually a set of related parallel tasks. Jobs are sequential. So I might have to actually allow somebody to place things into a shopping cart, and then that's when I can compute the total of the shopping cart, right? So that's sequential. I have to wait until the shopping cart is full before I do that. But computing the total, adding the tax, arranging the shipping, I might be able to do all of that parallel, simultaneously. And if there's a problem for payment, then maybe I have to back a few things out. And that's the way most of those operations run today. It's just that now we're trying to make them sort of standardized in some way. So jobs actually can support a continue action as well. The idea that something kind of went wrong, I had to phone home, Mike, can you help me? I rearranged something and I said, okay, keep going. Right? Just like we do with batch jobs today. Anybody who's worked in batch knows how to do this as well. Or I may need to restart from the beginning, give it some early values, beginning values, and restart the whole job. So jobs, along with this idea of canceling, need this idea of resuming and from restarting. So tasks run in parallel, jobs run in sequence. This is a language that we need to get used to thinking about. So what does this add up to? Well, it adds up to the thing that I just showed you in the start of this talk. I call it a RESTful job control. It's kind of lame. I don't know. There's probably going to be some better way to describe this. Maybe somebody's already doing something like this. But what we want to do is create a way to compose things that have never met before and use them to create a solution without having a lot of custom code to do it. And we can do it through basically configuration or a document entry. What we want to do is create this network of the way things interact with each other. I know this is hard to see. You'll be able to look at the slides later. But basically, we have a list of jobs. We have one or more jobs. Any generic job client or composer client could walk through this list and handle these jobs because it just needs to know how to do those steps. And the real functionality, the real elements involved, like you can think of them as Lambda functions. That's the one that computes the tax. That's the one that computes the total. That's the one that handles shipping. And all we're doing is gluing them together. Now, I've got some other details on what a job record looks like, the ability to, say, have a timer and have a maximum amount of time. If I don't hear from anybody in a while, I'm going to cancel this job. And when I cancel the job, that's going to kick off a revert for others, things like that. Task records are pretty much the same way, but they operate on slightly different set of operations, but it's basically going to be the same thing. And then there's a set of rules. There's some basic rules about what a composable service looks like, how I can do a backout, what happens if I receive a cancel from somebody else, and I detail some of this. This is just, basically boilerplate and some thinking through of what an action might be. But by creating these sets of rules about what is a job and what is a task, we can handle 80% of the challenges right here. So this also leads to, I showed this earlier, this notion of when I write a service that's supporting composability, I just need to have a few functions that are up and available and ready. And then once I have an answer for every one of those, sort of like an abstract class, and if you're doing object-oriented programming, then I'm all set. I know that I'm going to be safe. And the document, I did this document in HTML simply because I wanted to use HTML, but you could use any structured format you want. You can use JSON, you can use Siren, you can use collection JSON, HAL, anything like that to describe the URLs that are necessary. And you only need to write one client, or maybe even one client module that any application can use in order to start running jobs. And we saw this before. Now, it's not easy. There's some challenges. Composability is actually, in the way I'm describing it, a set of external behaviors, not internal. I have to be able to support undo. I have to be able to support repeat. I have to be able to support continue and all these other things. That's a challenge. We're going to have to start rethinking the way we code our services in order to do that. We don't often think about what it's going to take to roll back. We just think magically it's going to happen. It could change a lot of how we think about what is a composable service, and it means not all services are going to be composable. We need to think a lot about this notion of parallel and sequential actions and options. Parallelism is a thing also that we're really not in the habit of doing a lot of. Often when you create services, you say, I'm going to generate a client record, then I'm going to take the client ID, I'm going to use that for the job record, and then I'm going to take the job ID and the client ID, and I'm going to use that. We have to stop doing that. We have to start generating our own IDs and orchestrating those. The same way we've been doing with Kafka and all these other tools that are streaming. We generate IDs, right? Take that knowledge and bring that back to us. And then shared state is a foundational element. Creating a shared state document and keeping that within our transaction space, securing it, that's going to be a little bit of a mental challenge, but it's not that hard. It's not that difficult once we get the hang of it. So external behaviors, parallel and sequence, shared state. These are some of the big challenges. So if we want to mix services at runtime, we need to make these decisions ahead of time. So if we want that composable business, let's get some composable services. Let's describe the things we have. Let's run them in parallel as much as we can, and then that allows us to kind of mix things together. That's what I think the future of composability looks like. It's not the only possibility, but I think it's one that we can do already today with all the technology that we have. We don't have to invent anything, and I don't need a custom platform. I don't need to install an Apache product or some open source product or a proprietary product. Anybody can build these things. Everybody can build these things. So I'm going to leave with one quote from Donella Meadows, who's known for the book Thinking in Systems. A system is an interconnected set of elements that's coherently organized that achieves something. This is what I'm trying. I may not have made it, may not be successful, but this is what I'm trying to do. And I think the most important element in that is interconnected. We're interconnected in so many ways. Let's take advantage of that and make that the feature of this idea of composability. So that's what I have. Hopefully I'm getting you thinking about some things, maybe asking some questions. We've got a couple of minutes left, I think, if somebody's got some questions. And I'll be around, so we can even after that. So
we have time for a few questions. Who wants to start?
Uh-oh.
I'll start. I'll start with the question. It looks like kind of a language for make kind of smart contract, not blockchain smart contract, but like, things that are...
Yes.
And I was talking to a researcher in web services 10 years ago. She was trying to do like, for example, I want to order my flight, but unless I have a car I can rent, I don't want the flight to be confirmed, right?
Right.
So this language you're creating, this job language, whatever, that would help web services to wait for an answer, and then we can go to, unless it's $2,000 or when it's below 2,000, apply that. So how complex it can be.
So that's a really good, you mentioned a really good point, and that is there's some logic language, and there's some ifs and thens and so on and so forth. What I'm advocating is putting all of that logic in the services, not in the composability, right? So you might create a service that says, I will rent a car under the following circumstances, and I might give it a rule, but that's the service rule. It's not the composability rule. And that frees up all of this composability from the sequential actions of some kind of state diagram that I have to traverse. Here, it's just a pile of things that I'm going to do, and that service, in the case that she was describing, would say, I'm sorry, I can't get this car. You're going to have to revert the flight.
Yeah, so
right?
Like this, you can have this. And so every service would have a name like an I, like I rent cars, I look for price, I book tickets,
It could, and I'm not describing those features. Yeah. I don't think that's the external part of the composability. Those can be built in, and people can be as creative or complex as they want. They might even implement their own decision engine.
So
AI might get involved in this and lots of things.
So there is an API for that. There will be a job for that.
There's a job.
Yeah,
Yeah.
there is a job for that, right?
Yep.
So much I want to ask you. Too, like when I'm first thinking about this, it comes to like React or whatever the other one is, and you have components, right?
Yep.
And the components are the things that are actually giving you the functionality wherever it is. My thing about this, though, is two questions. Are you saying that composable services are services that we can get from other places like weather, currency, blah, blah, blah?
Yep.
If that's the case, what's the standard in the language or in the framework? Or because it's composable of a lot of different things, so there has to be some standard.
Yeah, so that's right. So if I understand the question is fine. If it's services that other people have created that I'm not hosting, how do I know that they're going to match? How do we know that we're going to communicate with each other? That's the document that I was describing. So a service document would have all the URLs for start and cancel and revert and timeout and where to find the state resource and these other things. So that would be a document that could be written at runtime, or it could be a template that writes lots of them when, at midnight or something. That's the only language we need to share. Sort of like the way get and put and post and delete are the only language we need to share for services. So that's the idea behind it. Yes, good.
Yeah, so you mentioned shared state. You also mentioned idempotency, which is often used for eventual consistency as opposed to continuous consistency. Just curious if you can comment, with shared state, is it typically an eventual consistency situation, or is it usually continuous, or is it both?
Okay, so that's really good. So the question is about shared state and consistency, right? So the shared state that I'm describing and the ones that I've used are totally local to this running job. So it's this running job's copy of Mike's company record or something like that, which may or may not be reflected by the persistent storage right now. In other words, the consistency may not be the same as my shared state as it is to the persistent state, but I may have gotten a guarantee. There may be some transaction that says, yes, you're queued up to write Mike's record, and eventually I will. Most of the time, my experience has been those eventualities are on the microsecond level, but occasionally if they're going to be very long, I didn't include it here. I actually have an additional pattern that I describe, which is basically using 202 accepted in REST, which basically says, I'm working on it, I'm telling you now it's not done. If it's important to you, wait for something else. So that's a way to handle the longer, if you expect longer wait times. Yeah, it's a good, yes.
Yeah, unfortunately, we're out of time, but that was quite interesting. It's quite a good surprise. You about like a glimpse into the future about what it could look like. Thank you very much, Mike, for being there with us.
Thank you. Thank you very much.